Hello everyone, I am your Baba Sagar from It's My Science Cafe. In this class, I am going to teach you magnetic properties of transition metals. When the magnetic field applied to the substances, two types of substances are going to form. One is paramagnetic substances and another one is diamagnetic substances. What are paramagnetic substances? The substances which are having an unpaired of electrons. The substances which are having unpaired of electron, that is called as a paramagnetic substances. What are diamagnetic substances? The substances doesn't have a unpaired electrons, or the substances which are having a paired electrons, that is called as a diamagnetic substances. In this class, we are going to study paramagnetic properties. Why paramagnetic properties we are going to study? Because when we are talking about the transition metals, almost all the transition elements will show the paramagnetic only. Because why? You know that all the transition metals. How you are going to say transition metals? Transition metals having in their valence shell D1 to D9. That means D1 to D9 will be there. That means what? Unpaired of electrons will be there. So presence of unpaired electrons makes the compound paramagnetic. Paramagnetism arises from the number of unpaired electrons and also associated with the spin angular momentum. Spin angular momentum, that is when we are writing any orbitals, that you can see that electrons. Okay, in this when we are writing the electrons, so this unpaired electron, this is a paired electron and this is a unpaired electron. Single electron is there, that is unpaired electron, and this is a paired electron. That's why paramagnetism associated with the spin angular momentum and also associated with the angular momentum. So now, if the number of unpaired electrons are more, when the number of unpaired electrons are more, then what is going to happen? Paramagnetism will be more. Now, we will understand paramagnetic properties of transition metals briefly. So, when the presence of unpaired electron is there, so during that time what we are going to see? We are going to see spin angular momentum and also angular momentum we are going to see. So now, due to the magnetic properties we are studying in this, so that what we are going to study now? Magnetic momentum. Magnetic momentum of this compound we are going to study, that has been given by the Bohr. Hence it is called as a Bohr magnetic properties. So now Bohr have given the formula, that is magnetic momentum mu is equal to square root of n into n plus 2. So here n is equal to number of unpaired electron. Since we are talking about the paramagnetic properties, so there will be unpaired electrons, hence what we are studying paramagnetic properties. So what we are going to see? Number of unpaired electrons we are going to take. Okay, so now if the greater the number of unpaired electrons, greater will be the magnetic properties, and hence what is going to happen? Greater will be the magnetic moment. Okay, so now one by one we will understand. See, I already told you paramagnetic properties we are going to see in the transition metals or its ions. Okay, when the unpaired electron is present in the transition metals or its ions, okay, so that only we are going to, from that we are going to understand paramagnetism of that particular compound. If the number of unpaired electrons are present in the transition metals or in their ions, then we can going to see the paramagnetism. So based on this we can take the number of examples and we can solve. So first I will take first transition series. Examples of first transition series we can take and we can solve. So for example, when you if you want to calculate the magnetic momentum of the scandium, okay, first children, write the scandium. What is its atomic number? 21. What is the electronic configuration of this? Argon 3d1 4s2. Here in the D, number of unpaired electron is 1. Okay, so D1 is there, so it's an unpaired electron. S2 is completely free, so you can't take. So in the D, 1 unpaired electron is there. So N is equal to what, children? N is equal to 1. So apply unto the formula which I have given. So what is the formula? magnetic momentum, that is mu is equal to square root of n into n plus 2. So here square root of n is equal to 1 I have told, so 1 into 1 plus 2 you can take. So how much it will come? Square root of 3. Square root of 3 you will get. So you already know how to remove the square roots. Okay, so simple method I am also having. Okay, so it is a long division method, it is there, that I will teach you. If you have a simple method other than this, you can use it. Otherwise, if you are comfortable with my method, then you can go with my method also. Okay, we will remove the square root of this. Sir, already they have calculated the magnetic momentum, and what we are doing is we are going to calculate in order to check the answer, whether the answer is correct or not. There are two data they have given in your textbook, that is observed also they have given and calculated is also given. So observed and calculated, there will be some small variation is there, so in that you don't want to get any tension. Okay, how much you will get by doing this, that is okay, understand? So if you take the root 3, first children you have to do the long division methods. I will explain it. So 3 is there. So now just to check that on which number it is going to divide easily. Now here you have to understand properly whatever the number you are writing here, from which you want to divide that number. So that number, and here you have to write the same number. For example, so 3 is there. 3 ones are 3 you do sir, so it will be getting 0 sir. No, you should not do that. What is going to happen when you are writing the number here, which number you are going to write, and that number only you have to write here, and when you do that, the number which is coming over here will be less than of this number. So you should not take the 3. So if you take the 3 here, here also you have to write 3. 3 3s are 9, so it is not a less than. Clear? Once again I am telling, whatever the number you are writing here, that number only you have to write here, and the answer you have to write here. So answer will be less than the given number. So now what you have to do, I can't take 3 directly. So first I will go with the small numbers. So 1 I will take here. So if I take 1, here also I can take 1. So 1 1s are 1. So 2 is remaining. I can take 2 because if I take 2, here also 2, here also 2, 2 2s are 4 will come. So it is more than this 3. Okay, I will explain this one example. So all you can do for the remaining example. Same method you can apply for the remaining example. Okay, 1 1s are 1, so 2 will be there. So now what you have to do, you need to add this number and you have to write here for the second step. So 1 plus 1, 2 is there. So both are equal number. So if you are doing 2 1, if you are writing here now, if we are writing any of the number here, okay, if you write any number here, so that number you have to write here. So if you are writing here, if I am writing 1, then you have to write here also 1. So 21 ones and 21 will come. So this number is a small. So what you are going to take? So you are going to put the point over there. So when you put the point, what is going to happen, children? Here you can put 0. So it is also agreed to. One more digit, 10 digit will come. Why? Now you are going to place one more number here. So if I keep 1, so here also I want to put 1. So here 0 is not enough. So what I am going to do? So that number will become a greater number. So one more 0 I will do and I will make it 100. So I am going to divide by this number. 10s I am going to do. So here I will take hundreds. Okay. So if I now you do the division. So whatever the number you want, see if you take 1, so 21, 1s are 21 will come, so it is a greater number. So like that, if you are keep on doing, you just keep on trying with another number, whatever the number it will be easily given, that number you can do. So if you are trying with the 2, 22, here also 2 you have to put 2, 22 2s are 44 will come, so 44, but it is very less than 200. So in which number you have to do? So I will like that, if you keep on trying, I can go with the 7. If I will do the 7, see, have a small multiplication. If I am taking here 7, I want to put here also. So 27 into 7, 7 7 is 1, 4, 8, 189 will come. How much it is going to come? 189. So less than 7 I can't take, less numbers you will get. So if I will go with the 8, 28 8s, it will be coming more than 200. So I can't take that. So 7 is the proper number. So I have taken the 7 over here. So here also I need to do 7. I want to write here also 7. So see children, how much I was getting? 189. So what is the remaining? 11. Okay children. So now at least after the point, at least 2 digits you need. Clear? 2 or 3 digits you can go. 2 digits I will take. So 1.7 I got. So now next step, same step for if you want to move forward, same step you are going to apply. For that what you have to do, I already told you this number and this number. You have to add 27 plus 7, 34. That number you place here. So this already 2 digits are there. One more digit you are going to take here. So what you are going to do here? Again you are going to put 0. But 37 is, if you are giving one number also, it will be 341, 42 like that it will be there. So more than that. So one more 0 you take and make it as 1000. Okay. Once again I am telling, here if it is 10 is there, inside it should be 100. Here it is 100, then it will be 1000. Clear? Like that, so on, it will be increasing. Clear to everyone children? So I already know the number, so that what I will do now, so I will directly take, I will take here 3. So if I am going to take 3, I want to write here 3. So 343 into 3 if you do. So 3 3s are 9, 3 4s are 12, 2, 1 remaining, 3 3s are 9, so 1, 10. So 1029, 1029. So just calculate it, how much it will get. You are going to get 71. Okay, you can do the next steps if you want for one more digit, otherwise 1.73. So what is the calculated value for this root 3? It is 1.73. If you have an easiest method, you can apply it to your children. Okay, so now listen carefully. Whatever the observed values are there, in your textbook it is there, whatever the observed values are there, that observed values are always vary. So don't compare with the observed values and calculated values. So it will be plus or minus plus 3 or 4. So no problem. Okay. So if you are taking the number of unpaired electron, what is the calculated? It is 1.73. What is the actually observed is, that is 1.75. So 0.02 variation is there. So no need to worry about that. Clear to everyone? So you can do it for the many example you can take. You can take further. You can take scandium only I have given. So for scandium is there. So you can go with another also. Scandium 3 plus you can take. Scandium 2 plus you can take. Sorry, not scandium 3 plus. Scandium 3 plus doesn't have any unpaired electron because argon 3d1 4s2. So if you take scandium 3 plus, 0 will be there. Okay, for scandium 3 plus there is no unpaired electron, so you can't calculate. So 0 unpaired electron, so 0 answer will come. So you can go with titanium 3 plus. If you are going with titanium 3 plus 1 unpaired electron will come. Okay, either you can do with the metals, you can do, otherwise you can go with ions. So I will not take much time. I will explain one more example with ions. Say for example, sir, explain the titanium 3 plus. Okay, so if it is there like this. So first you write what is actually titanium. This is the atomic number of titanium 22. So what is the unpaired electron? I will write from the 3D only. 3D to 4s 2. So 2 unpaired electrons are there in the D. So number of unpaired electron is 2 here. Okay. If you take the titanium 3 plus, how much it will be there? 3D 1, 4s 0. Actually, titanium is 3d2 4s2. From this 3 electron removed means 3d only 1. So 1 unpaired electron. Again, what is going to happen? 1.73. So same method, children. You go with the different ions and you can solve for the other examples. Same method you can apply for the other example also. So see, now scandium I told, titanium I said. Okay. So common examples if you are taking. Scandium 3 plus if you are taking with its oxidation number, scandium 3 plus ion if you take, this is having a 0 unpaired electron. How 0 unpaired electron? You can write its electronic configuration also, that is 3d0 4s0. Okay, why 3d0 4s0 will come? See, actually the scandium is how much? Scandium is argon 3d1 4s2. So for the scandium 3 plus, D also 0 is there? S also 0 is there. So what is going to happen? There is no unpaired electrons. Clear? So we take the titanium 3 plus. Here the electronic configuration will be R1 3D1 will come. Why? In the last example I said already, titanium is R1 3D2 4s 2 is there. So in this, if you remove 3 electrons, it will become R1 3D1. So 1 unpaired electron. So scandium 3 plus ion doesn't have any unpaired electron. So 0 unpaired electron, 0 magnetic momentum. And if you go to the titanium 3 plus 1 unpaired electron is there. That how much it is going to come? 1 unpaired electron for scandium we calculated, that is 1.73. Okay. So same, if you are taking the titanium 2 plus you can take. If you take the titanium 2 plus, how much it is going to come? So only 2 electrons you are going to remove. So if you remove these 2 electrons from the titanium, so it will become 3D2. Then also it is unpaired only. So how many unpaired electrons is there? 2. Clear? So same way, by knowing its oxidation states. So if you take the first transition series, whatever the elements having their particular oxidation state, based on that you can take the number of unpaired electrons. Okay. Based on the oxidation state, I will write all the ions of first transition series. So how many number of valence electrons will come? So that all those things we are going to discuss it later. So you can have a look on the board. First transition metals I have written, metal ions I have written based on their oxidation, common oxidation state I have written. So if you are seeing the scandium, which we already discussed, so you know the electronic configuration, how to write and how to make them into ions. I have already explained it. Okay, scandium 3 plus is there. So in that the scandium, 3 electrons if you remove, so it will become 3D0. So 0 unpaired electrons is there. So magnetic momentum also 0 will come. You will get. So titanium 3 plus is there. So 3D1 will come. That means how many 3 electrons it is going to be removed from the titanium? So 3D1 3 plus titanium 3 plus will become 3D1. So number of unpaired electrons will be 1. So if you go to the titanium 2 plus, if you do, so 3D2 will be there. So number of unpaired electrons will be 2. So if you go to the vanadium 2 plus, so 3D3 is there. So 3D3 means how many? So 3 unpaired electrons are there. If you go to the chromium 2 plus, 3D4, so 4 unpaired electrons. Clear? So moving to the manganese 2 plus, if you take 3D5, so 5 unpaired electrons. So manganese is having 5 highest unpaired electrons. Manganese is only having the highest unpaired electrons. So if you are taking the iron 2 plus, see again 3D6 you are going to get in the iron 2 plus. Okay, the iron 2 plus how much? 3D6. So in the 3D6, you can write this one. See, I will write for the 3D6. Still manganese unpaired electron will be 5, only 5, because 1, 2, 3, 4, 5. That means 5 subshells are there, so you can write 5. So in the after 5, fifth electron. So what is going to happen? It will be like this. Till 5 will be like this. So after 5, sixth electron will be taken over here. So unpaired electron, how much you can write? So only 4. In the iron, 3D6 will be coming. So 4 unpaired electrons. If you take the cobalt, 3D7 is there. So see, 3D7, so 3 unpaired electrons. So nickel, 3D8 is there, so 2 unpaired electrons. If you go to the copper, so 3D9 is there, only 1 unpaired electron. If you take the zinc, 3D10 is there for zinc 2 plus. Okay, cobalt 2 plus, nickel 2 plus, copper 2 plus, zinc 2 plus. 2 plus only I said, okay. So if you take the zinc 2 plus, 3D10 is there, so completely filled. So there is no unpaired electrons. For your quick revision, we will do, we will write the number of unpaired electrons of all the first transition elements. So scandium 3 plus, how many unpaired electrons? 0. Titanium 3 plus, 1. Titanium 2 plus, 2. Vanadium 2 plus, 3 unpaired electrons. Chromium 2 plus, 4. Okay, I will write the manganese 2 plus 1 here. I will write 5. Here I will write it is 5. Iron 2 plus 4 unpaired electrons. Then cobalt 2 plus 3 unpaired electrons. Nickel 2 plus 2 unpaired electrons. Copper will be 1. Zinc will be 0. Students, you should remember or you should know how to calculate the magnetic momentum for unpaired electron up to 5. After 5, what is going to happen? Same number only it is going to come. After manganese, the number of unpaired electron will be going to decreases. Okay, 4, 3, 2, 1. First it will be 1, 2, 3, 4, 5, 4, 3, 2, 1. Okay, for that purpose what you have to do? You should remember For you should remember or you should know to do the 1 to 5. Okay, same method which I have given. Magnetic momentum is equal to square root of n into n plus 2. This formula you have to use. Okay, same formula you use. Take the number of unpaired electrons and apply for this. Clear? I hope you understood magnetic properties. So especially you need to keep it in your mind, paramagnetic properties of transition metals, because transition metals having unpaired electrons. Hence, more the number of unpaired electrons, what is going to happen? More the paramagnetic properties. That means more magnetic momentum you are going to see. Until my next video, you keep practicing, keep learning, and those who are not subscribed to my channel, please do subscribe and click on the bell icon to get my notification of all the videos. Thank you.